At the next question here in the miscellaneous problem, the question is this is one of the great question. Here you will find some difference, and this question will help us to give this question answer that what is the limitations of dimensions. This question is giving a overlook for how we can write limitations of dimensions. Now, my dear, here the question is Reynolds number is dimensionless. Here I have represent Reynolds R and number is N. So NR. Reynolds number is dimensionless quantity. Matlab it is given that it is dimensionless. Dimensionless right now I have told in my first video. Dimensionless is L power 0, M power 0, T power 0. So it is dimensionless quantity, and sir it is a number, so of course it is a dimensionless. Nothing worry about it. It is a number. So it is dimensionless. But then they said that determine the conditions. This Reynolds number determines the condition of laminar flow of viscous liquid through pipe. My dear, I'll tell you what this Reynolds number is. That's what that line is saying. My dear, there is a two kind of a flow in a liquid when it is flowing through pipe. Please, because I'm using a word viscous and I'm using a word viscosity. You all know earlier in my video I'll explain all these topics. As we are walking on the solid exert the frictional force. Similarly, when we move through the liquid exert the viscous force, and that gives a viscosity. That is a property of that liquid, that it exert the viscous force. Viscous means it opposes our motion. Okay. So my dear, when any liquid which has a property of viscosity, that is to oppose our motion, when any liquid flows through a pipe, there is a two kind of a flow is occurred through a pipe. One is a streamline flow. That is, flow is streamline. My dear, streamline means whatever amount of water entering the pipe in 1 second, same amount of water will leave the pipe in 1 second. I mean to say that the water tap which is in our home, in our houses, the water which is coming through the tap is streamline. And another flow is turbulent flow. That is, when there is a flood in the river, then such flows are called turbulent. I repeat, another flow is a turbulent flow, or when there is a choke up, right? Or when there is a flood in the river, then the flow is turbulent. Otherwise, the flow which is through the tap, right, in our houses is a streamline. Okay. So now, my dear, these are the two kind of flow. Streamline and turbulent, and laminar is a part of streamline. It is almost all laminar flows are streamline. So my dear, this Reynolds number, all laminar flows are streamline. This Reynolds number determines what it determines, whether the flow through the pipe is a streamline or whether it is turbulent. Okay. So you understood what is Reynolds number, sir? It determines whether the flow. Determine means by value, by some value. I am not going in deep. We will discuss all in property of fluids. But right now I am superficially teaching this part, that sir, this Reynolds number, which is the word given, determines the flow. And there are two kind of flow. One is streamline and other is turbulent. So it determines whether the flow is streamline or whether the flow is turbulent. Here the streamline word is given as a laminar, because all laminar flows are streamline with some basic more properties in streamline, laminar. So no issues about it. Laminar flow is a streamline flow. Okay. If NR is a function, I said NR is a function of. My dear, here the important word is function. I have nowhere I have written depends. My earlier numerical is based on the word depends, but here I use the word function. My dear, function is also the same meaning. If I say my all student is function of mine, it means that what I am doing, accordingly my all student is doing. Right? So function is also a word related to depend. So take care, here it means Reynolds number depends on what? On density of liquid, that is rho, clear. Function means depend. So it depend, NR is depend, Reynolds number is depend on density of liquid, on speed of flow denoted by V, and on coefficient of viscosity denoted by eta. Okay, so now here I am getting, by these three alphabets I am getting solution here. So I hope you understood the word laminar. Laminar means streamline kind of flow. Or there is another flow, turbulent, which is measured by Reynolds number. But we are not having the idea about this, that what is that values and all that, because that's not a question. Question is dimension. So please, I mean, it's my duty to tell you what is this Reynolds number, and therefore I have briefed you that the Reynolds number actually measures the flow, whether the flow through the pipe is laminar, that is streamline, and whether the flow is turbulent. Because, and what is streamline, my dear? The flow which you can see through your water tap, or through your my dear, when you are taking that what you can say RO and all that, the flow which is coming through any tap is streamlined, unless and until the speed of the flow increases. So that's not a question. Question is that the Reynolds number is a function of, so NR is a function that is depend upon density of the liquid. So here NR, I am writing NR proportional to, that's a function. Either it is proportional directly or it is proportional inversely. That's we don't know. It depend inversely or directly, we don't know, but it is depend on density, it is depend on speed, and it is depend on coefficient of viscosity. But my dear, since I don't know whether it depend directly or indirectly, okay, so I will put it over here as A, B and C. If power of A, if answer of A is negative, I will say Reynolds number is inversely proportional to density, because once it become negative, it will be 1 upon rho. If power of B becomes negative, it will be inversely proportional to velocity. So if any of these power become negative, this Reynolds number will be inversely proportional to that. But my dear, here they have given one more statement. Also NR, that is Reynolds number, is directly proportional to diameter. Try to understand this. Reynolds number is directly proportional to diameter. Matlab, here they have told us that it directly proportional to diameter. Here he is confirmed. The question is confirmed that Reynolds number is directly proportional to diameter, not inversely. So that I can write here directly proportional to diameter without any power. Here I will not mention any power, my dear. Why I will not mention any power? Because sir, you already know it is directly proportional. But here we don't know whether it is directly proportional to rho or V or eta, or it is inversely proportional to rho, V or eta. And therefore I put A, B, C, because here they said this is a function, NR is a function of density, velocity and eta. But they have not mentioned anywhere that it is a function directly based on or inversely based on this. But in this last statement, my dear, there they mention that NR is directly proportional to diameter. So here this last statement here where you have confirmed that Reynolds number and diameter are directly proportional. But in the previous statement, my dear, you are not confirmed whether Reynolds number and these three quantity may relation are direct or inverse. So my dear, this is what is a very important question, and I am sure till now I have not uploaded this kind of a question, and therefore I have taken this part. So let's move on to the next part of it. Now here, my dear, the next step is therefore NR is equal to, this is K rho A power A, V power B, eta power C multiplied by diameter. Here I have not put anything on diameter because from previously we know that Reynolds number and diameter are directly proportional. But all these three quantity we don't know. We know only this much, that Reynolds number is a function of this. But whether it is direct function on this or inversely depend on this, that is not given. And that will determine by power A, B, C. If power value is positive, sir, it is directly to them also. But if the power value is any of the power is negative, then this will be inversely to that quantity, inversely proportional to that quantity. Okay. So I hope till now everything is clear. What is laminar flow? Sir, it is a streamline flow. There is a two kind of a flow. One is streamline, other is turbulent, right? And the flow of the water through tap is generally a streamline. But flow in a river is a flood in a river when occurred. When any river there is a floods occur, that flows are turbulent. कौन कहाँ चले जाता है पता नहीं चलता. And that flows is determined by this question, this number called Reynolds. Okay, so and I hope rest all is clear that sir, Reynolds number is a function of density, speed and viscosity, but sir, it is not clearly mentioned whether it is direct function on that or inversely depend on that. Here function is a word related to depend. Please take care, that is critical situation, otherwise you will start searching the word where is a depend. Function itself means as a depend, but it doesn't mention that whether nr is depend directly on them or inversely on them, and therefore while writing over here I put them a power, put a power on them, where if a become positive then it will be directly, but if a become negative then there will be inversely. But in my last statement, my dear, nr is directly proportional to diameter, it is clearly mentioned, and therefore my dear, I have written nr directly proportional to diameter. For this I will read it is directly proportional because it is mentioned. And here on that I will not put any power because from previously only I know nr and diameter are directly proportional. But for rest of them I don't know, and then I start doing it. So let's begin the rough work for finding the dimensions of each and every quantity. Let's start for it. So let's start for the dimensions of this quantity, my dear, here. So the first quantity is given as the rough work. Here I am doing rough work. The first quantity is Reynolds number nr. It is dimensionless, already given. That is dimensionless. So it is nothing but, my dear, L power 0, M power 0, T power 0. So Reynolds number is over. Next is, my dear, density. Density is nothing but mass upon volume. That is dimension of mass and dimension of volume. That is M power 1 and L power 3. So the dimension will be nothing but L power minus 3, M power 1, T power 0. Next is, my dear, the velocity. Dimension of velocity. Velocity is nothing but distance upon time. If you know dimension directly, you can write dimension. If you don't know, then you should write this way. This is L power 1, T power 1. So the dimension will be L power 1, M power 0, T power minus 1. Next is dimension for eta. Coefficient of viscosity. My dear, coefficient of viscosity has the formula force divided by area into velocity gradient. I hope it is clear. Force upon area is called, my dear, pressure. You can say pressure, and this divided by velocity gradient. If you remember, my dear, so dimension for eta will be nothing but dimension of pressure L minus 1, M1, T minus 2 divided by velocity gradient. My dear, I hope you all know velocity gradient has the dimension of, everybody, this is velocity upon distance. That is velocity gradient. Please, everybody know about it. Any language, any quantity is named with gradient. See, first I have written this, and I hope abhi tak, till now, you should learn these dimensions now. Don't go all this because now we are done very much. But still, my dear, if you don't know, then eta has a formula force upon area into velocity gradient. And force upon area is pressure, because instead of, or you can write force ka dimension, area ka dimension. And when you solve, you will get this. Okay, but I have converted force upon area as pressure. Say I remember the dimension of pressure, so I have written dimension of pressure L minus 1, M1, T minus 2. And for velocity gradient, you all know that it is a gradient, so velocity will divide by distance in my all dimensions quantity. So velocity divided by distance, nothing but, sir, L1 and M0, T minus 1, that is dimension of velocity divided by L1. So the dimension for velocity gradient will be L0, M0, T minus 1. So here it is L0, M0, T minus 1 is the dimension of velocity gradient. So here it will be L minus 1, M1, and minus 1 of T will go up, become minus 2 plus 1, that is minus 1. So this is the dimension for coefficient of viscosity. Am I clear? And the last is the diameter dimension. Dimension of diameter, that is nothing but L power 1, M power 0, T power 0. That is the dimension of diameter. Diameter is length only. So it is L power 1, M power 0, T power 0, because any diameter will represent in meter or centimeter. So this is all about your dimensions. Here I request, my dear, among these four quantities, rho, V, eta and D, I hope eta only the important one, rest all you should aware about. Second, NR is already, Reynolds number is already dimensionless, so I mentioned del 0, M0, T0. So now for this, my dear, I think till now we have done so many times the eta ka dimension, so that we should learn it. It is L power minus 1, M power 1, T power minus 1. L power minus 1, M power 1, T power minus 1. Otherwise, my dear, if you don't remember, then remember the formula. It is force upon area into velocity gradient. Substitute each dimension. Substitute dimension of force, substitute dimension of area, substitute velocity gradient ka dimension by formula velocity upon distance. Okay. Substitute each dimension, force, area, velocity gradient. I am sure you will come down to L power minus 1, M1, T power minus 1. Or force upon area is pressure. So you can write pressure upon velocity gradient. And if you remember the dimension of pressure directly, write down that. Write down dimension of velocity gradient, that is L0, M0, T power minus 1, and then calculate, you will get the value. So there is any way or any alternative method you can adopt for this, but please write a right dimensions for given physical quantity. Okay, now let's start for this. Therefore, this is Reynolds number, dimension of this will be L0, M0, T0 is equal to K. This is density, I have written density, this is L power minus 3, M power 1, T power 0, whole power A. This is velocity, this is L power 1, M power 0, T power minus 1, whole power B. This is eta, this is L power minus 1, M power 1, T power minus 1, whole power C, and this is diameter D, this is L power 1. I hope it is clear. This is L power 1. No any other power, because we directly know that Reynolds number and diameter are directly proportional. So we don't put any power here. पहले से मालूम है they are directly proportional. See the fantasticity. This is also a question where we can see. And what is the limitation? It means, my dear, कि more than 3 physical quantity पे dimensions का कोई भी proof नहीं है, my dear. There is no proof which give if the quantity on the left side depend upon more than 3 physical. See here, 1, 2, 3 and 4th is already mentioned by them. It's not unknown. It means more than 3 physical quantity is never being given in dimension. Please make a note of this. मैं क्या बोल रहा हूँ समझ लो. My dear, here 1, 2, 3, 4 quantity are there, and one quantity depend on that. Right? So now, my dear, there are in all 5 quantity. So what I said earlier, whatever proof we have done, we have only 3 quantity on right side. So and 1 quantity on left side, which is depend on that 3 quantity. So what I mean to say that, see, this is the limitation, this is the problem in dimension. That if there is more than third quantity, 1, 2, 3, if there is more than third quantity, that is 4th quantity, either they will give directly in their answer that they are directly proportional, inversely proportional, whatever be. Or, my dear, there is no provision in dimension to calculate the 4th quantity ka relation with the given quantity. There is no provision to calculate. If this one is not given, I would have not put here as the another unknown D. That's not possible. We cannot calculate more than 3 physical quantity if it is given the relation. So that's, please make a note of this. And this is the reason why when they mention the 4th quantity, diameter, they said that Reynolds number and diameter are directly proportional. That is, they have mentioned the relation. So please make a note of this. More than 3 physical quantity, if there will be, like this question, then sir, there should be mentioned that the 4th physical quantity and the quantity which depend upon on them should be what way they proportional to each other. That is, they should mention the relation. Otherwise, in dimension, we cannot calculate the dimension if there is more than 3 physical quantity. So this become a limitations, my dear. You can see my any example of uses of dimension where there is a dependency questions. You will find in all dependency question, my dear, there is 3 quantity on right hand side and 1 quantity on left hand side. No 4th quantity. And if there is a 4th quantity like this question, so there should be a way of putting a question, because question already mentioned that the 4th quantity is directly depend on the given physical quantity. They have mentioned it directly proportional. Matlab they have given the answer for 4th quantity. They don't ask us to find that what way this fourth quantity varies with NR, or what way the NR varies with this fourth quantity. They already mentioned NR varies directly with the fourth quantity. So again the relation is established to become only in three quantities because fourth is known. Please don't waste this class and lectures, because this is the limitations, my dear, my next topic. So therefore this is L0 M0 T power 0 is equal to K. Here my dear, L power minus 3A M power A T power 0. Now you all know how to multiply this all. This is L power 1 into B is B, M power 0 into B 0, T power minus 1 into B minus B. Now here my dear, this is L power minus C, M power C and T power minus C. I hope it is clear. L power minus C, M power C, T power minus 1 into C minus C. And here my dear, I am putting L power 1 as it is. You can see here it is L power 1. As it is. Am I clear? So shall I rub this side? It will be much better, because I noted the dimension of each physical quantity, so I am rubbing this rough wall. It is not in my use now. It is used only to substitute the dimensions here. Now it is not in my use, so I can rub it out so that I get a space. So here I will mention L power 1, the last one, this one. Okay, now what will be the answer? This is L power 0, M power 0, T power 0 is equal to K. This is L power, here it is minus 3A, okay, plus B, here it is B, and here it is minus C, and here my dear, here it is 1. So here I will write plus 1. Here it is 1, no alphabet, because directly proportional with diameter. Please mention make a note of such question. This is M power A, this is 0, okay, so A plus 0, and here it is C, so it is A plus C, and this is T power 0, it is minus B, and here it is minus C. Now no other time is there on that side. This is L power 0, M power 0, T power 0, this is K. Now my dear, I hope I have written everything. So it is minus 3A plus B minus C, and here it is 1 on L power, so it is plus 1. Here it is M power A, and this is C, so A plus C, and this is T power 0 here, it is minus B here, and here minus C, so minus B minus C. Now here I will say comparing, here I will put it as equation number 1, and to this I will put equation number 2. This I will put equation number 3, comparing index of both the side of equation 3. So I will get, my dear, the first equation minus 3A plus B minus C plus 1, minus 3A plus B minus C plus 1, and here L ke power pe all these are there, and here L power is 0, so this is equate with 0. Now here it is M power A plus C, and here M power 0, so here it is A plus C is equal to 0. This I will put it as 4, and therefore my dear, this will give me A is equal to minus C. This I will put it as 5, and the last one is minus B minus C, here on T to the power minus B minus C, and here T power is 0 is equal to 0. Therefore my dear, here I will get minus B is equal to C. You can see minus B, minus C will on this side, therefore B is equal to minus C. This is my equation number 6. My dear, A is also equal to minus C and B is also equal to minus C. You can see all, everybody. A is equal to minus C and B is also equal to minus C. So now my dear, if A is minus C and B is minus C, can I substitute? Substitute equation 5 and 6 in 4. So now what I will get, my dear? Fourth is minus 3A plus B minus C plus 1 equal to 0. Now Here it is minus 3, but A is how much, my dear? A is minus C. So here I put minus C plus B is also minus C. So here B ke jagah pe bhi also I put minus C, and here it is minus C plus 1 is equal to 0. So now minus 3 minus this will be plus. This is 3C. This is minus, plus minus is minus C. This is minus C plus 1 is equal to 0. So this is 3C minus 2C plus 1 is equal to 0. So this will give me, my dear, 1C, that is C plus 1 equal to 0. Therefore C is equal to minus 1. So I am getting, my dear, C is equal to minus 1 in my question, in my answer. Now let's go to the next part of it. Substituting equation 7 in 5 and 6. So my dear, you know, substituting A is equal to minus C and B is also equal to minus C. So therefore, my dear, A is equal to minus C. So this will be minus and minus 1 because C is minus 1. So A is equal to 1 and B is also equal to minus C. So that is minus and minus 1 because C is minus 1 here. Right? So here, my dear, therefore B is also equal to 1. This I will be take it as 8 and this I will be take it as 9. And now I will say substituting 7, 8, 9 in 1. So I will get, मेरे बच्चों, Reynolds number NR, here NR directly proportional to rho power A is 1, V, that is V power B is also 1, and eta power C, and C is minus 1, and D as it is. D is already mentioned from previously, so D as it is. So now, my dear, what is exact relation? NR is directly proportional to rho VD because rho power 1 can be written as rho, V power 1 can be written as V, and D is as it is D, and eta power minus 1, here eta power minus 1 can be written as, my dear, can be written as 1 upon eta. I hope it is clear. Because eta power minus 1 is 1 upon eta, therefore Reynolds number is directly proportional to rho VD divided by eta. Or this can be written as NR is equal to K rho VD divided by eta, where K is constant. So this is what is the relation. So now, my dear, here I can draw the three conclusions. That Reynolds number is directly proportional to rho. I can draw the conclusion here that Reynolds number is directly proportional to rho. Am I clear? Is that clear? Here I can prove. Thus, Reynolds number is directly proportional to rho. Reynolds number is directly proportional to velocity. Reynolds number is directly proportional to diameter, but Reynolds number is inversely proportional to the coefficient of viscosity. Directly proportional to density, directly proportional to speed of flow, directly proportional to diameter of pipe, but it is inversely proportional to coefficient of viscosity. So directly proportional to diameter was given in the question. Only this three dependency we were not knowing, which we have proved. So that's all, my dear. Now let's go to the limitations of dimensions topic, which is related to this. Here I wanted to show you that if there is more than 3 physical quantity, right, on the dependency side. So now, my dear, if there is more than 3 physical quantity, there is no method of dimensions is applicable. Here 4th quantity is given, but in the question they have given the dependency of this 4th quantity, that it is directly proportional. Am I clear? If there will be a 4 quantity and all 4 quantity का dependency अगर मालूम नहीं है हमको, so that is not possible with dimensions. So here you can see this is a fabulous question where I have taken 4 quantity 1, 2, 3, 4. But my dear, the fourth quantity का dependency is aware with the given physical quantity. I mean to say, fourth quantity diameter, how it proportional, how it varies with Reynolds number is already mentioned. Am I clear? So by dimension, we are calculating only the dependency for three physical quantity. I repeat, by dimension, we are calculating the dependency for only three physical quantity. Am I clear? In my question, there is a fourth quantity, but for fourth quantity, the dependency is already mentioned. Not with the dimension, I have calculating this fourth quantity. Take care of this. This will be the limitations. So let's go for the limitations of the dimensions. Now my dear, let's begin with the last part of this video that I have told you that I will discuss with limitations of dimensions. Limitations of dimensions means, my dear, I cannot use dimension everywhere. There is some limitation is given. Some limitation is given that you can use the dimension up to this limit only. You cannot go beyond that. And what are the limitations? What are the three important limitations I have jotted here on the board? First, the method of dimension. I have used three methods of dimension: principle of homogeneity, converging of one system into another system, and then establishing the relationship among different physical quantity. These are the methods of dimensions, my dear. The method of dimensions, or solving all these questions, you must be remember, there is no information given about to calculate the constant k. If you remember in my topics, I used to tell you, that this k can be substituted in different dependency, in different physical quantity, in different experiment, the value of k is different. But through dimension, we are not knowing that k value. So dimension method is failed to explain the k value, and k is constant, that is dimensionless. So first point is this, my dear, that the method of dimension which we have done does not give any information about the constant k, and that k was dimensionless. If you remember, I have done so many formula. T is equal to k 2 pi under root L by G, where this not 2 pi, this is T is equal to k root of L by G. This k is 2 pi I have taken, but I told you here it is 2 pi. In some other way where the k will be different, here the k will be different. But this k, which is constant, which is dimensionless, this k ka value we don't get. This k informations, the information of this k we don't get by method of dimension. Am I clear? So this is one very important point, that the method of dimension never give or does not give any information about that constant k which we are using, my dear. And that constant k is a dimensionless quantity, and it does not give, the method of dimension does not give any information about to know, how to know this k. Okay, and therefore we teachers say all students that put k as k only in different situations, don't put their values, because through dimension we don't know what will be k. Now next is, my dear, as why in my previous topic I told you that whenever you will see the method of dimension, you will see only three physical quantity. I have given the example, my dear. Here I have taken the example. If you remember, I have done all these questions, and that example I have taken. Here n is the frequency. If you remember, one of the question I have done in the frequency of the string depend upon length, depend upon linear mass density, depend upon tension. But I have not given any fourth quantity. I said frequency depend upon length, linear mass density and tension. But after linear mass density, after length and after tension, I have not given any fourth physical quantity. Similarly, in another example, if you remember, the very first example I told you, the time period of a pendulum depend upon length of the pendulum, depend upon the mass of the bob, depend upon the acceleration due to gravity. Yeah. But my dear, after giving length of pendulum, mass of bob and acceleration due to gravity, I have not mentioned any fourth quantity that this t is depend upon that fourth quantity also. No. It means if you see any example, if you see any method of dimensions example of this kind, you will find, sir, there is only three physical quantity on which the fourth physical quantity depends. Am I clear? But there is no more than three physical quantity on which the fourth, or that if there is more than three, it will be fourth physical quantity, and then this will be fifth physical quantity. So my dear, in all there will be four physical quantity. One will depend on the three. Am I clear? But one will does not depend upon 4 physical quantity. If like that, then my dear previous question, if you remember, the 4th physical quantity ka direct relation they must have mentioned in the question. In my previous example, you must have observed Reynolds number is directly proportional to diameter. There was 5 physical quantity, but they mention about the diameter के साथ में that Reynolds number is directly proportional to diameter. पहले से mention किया था. So ultimately again there in that question also Reynolds number का dependency we have to show with the 3 physical quantity because 4th is already mentioned in the question. So take care of that. That's a point, my dear. I try my level best to explain you this all. The method of dimension fails when physical quantity depend upon. That is, these are the physical quantity. So when physical quantity depend upon more than 3 physical quantity, more than 3 physical, it will be depend till 3 physical quantity. But if it will be more than 3 physical, then the method of dimensions fails. So this is the point very clear. The method of dimension fails when these physical quantity, here physical quantity is frequency, here physical quantity is time period. When this physical quantity will depend upon more than 3 physical quantity. But right now in my questions, whatever questions we have given you is only 3 physical quantity you can see, and the 4th physical quantity is depend upon that 3 physical quantity. Am I clear? But my dear, there is no 4th quantity on which this 5th quantity depends. So please take care of that. In previous question, I am mentioning बार-बार मैं आपको बात बोल रहा हूँ. In previous question, there are 5 physical quantity, but if you remember the 4th physical quantity and Reynolds number, they have given already the relation that they are directly proportional. Okay, so remember this. And the last one, my dear, the method of dimension fails to derive the relationship for trigonometric functions. Now what is trigonometry? If there is sine theta, cos theta, tan theta, ultimately they are angle, and angles are dimensionless. So वही वो dimensionless हो गया. But if there is a sine theta, cos theta, tan theta type thing, we say they are dimensionless. So there is no method is mentioned for this trigonometric functions, sine, cos, tan theta, etc. There is no method of dimension for logarithmic function. Logarithmic. There are 3 kind of functions in geometry, my dear. In algebra, we call it as algebra geometry. The trigonometry is logarithmic and exponentials. So logarithmic we write this way: log x, log y, log x, log y, etc. So there is no dimensions. When you say, anybody will ask you what is the dimension of log x, you have to answer that ki sir, dimension method is not there for logarithmic functions. Neither it is there for exponentials function, e power, exponential e. E is stand for exponential in power. That's called exponential. So exponential functions, that is e power x, e power y, e power z, e power minus t. There is no method is given in dimension for exponential, for logarithms, and for trigonometry. So my dear, I hope these are the 3 limitations, the broad limitations of the dimensions. So please take care of this. These are the broad limitations where we cannot apply the dimensions method. The first dimension method is fails to give any information about the constant k, which is dimensionless, right? We directly substitute k. There is no method for calculating that k ka value by dimension. Second, my dear, that the dimension method is fail if there is more than, if any physical quantity, right? We have done depend wale questions. So if any given physical quantity will depend upon more than 3 physical quantity. Am I clear? There the dimensions method will fail. My dear, if there will be 4th physical quantity given, then definitely my previous example, then definitely uske saath mein the relation is already being given in the question. In my previous example, Reynolds number and diameter relation is already mentioned, right? So remember this, that if dimension method is fails, my dear, if any physical quantity depend upon more than 3 physical quantity. Till 3 physical quantity it is okay. Okay. Now and last, the method of dimension is fails to explain, my dear, or give any relationship for derive any relationship for trigonometric functions. There it cannot help. It cannot help in logarithmic functions, and it cannot help in exponentials functions. I have given the example how they looks. Trigonometric looks this way, logarithmics looks this way, and exponentials looks this way. So if anybody will ask you what is the dimension of e power z, say directly, sir, there e power z is an exponential function and there is no dimension exists according to limitations. That's all from my side. Jai Hind.